Good morning, 8th grade. Welcome to week 6, day 2. Today is April 28th. We are continuing with solving systems using the substitution method. Today we're going to be exploring when we're given a system and both equations are in standard form. So I'm going to click on our classwork tab. Remember, you have your agenda there to always be mindful of what we are expecting out of you for the week. I'm going to go to day 2. So if you click on the lesson, there are 2 links here today for additional support if needed. The first one is the one that I sent most of you yesterday, just as a reminder or a heads up of where we were moving today. So if you previewed that already, then you don't need to look at it again. If you haven't, then I recommend looking at it. I think this guide is very helpful and walks through very similar examples to what I'm going to model as well. Okay, so I'm going to click on our lesson. The first warm-up question is very similar to what we were doing yesterday, where one of our equations is in standard and one of them is in slope-intercept. A number of you guys did a great job with this. I really enjoyed seeing your work that you did to get to those answers. So I'm happy that we incorporated this into our normal routine at this point. We are going to do the same thing today where you're going to answer the form, but you're also going to submit your work. So just be mindful that I will be looking for both of those assignments. Okay, so your warm-up is worked out for you. Remember, you plug in for y, distribute, combine, inverse, and then we look back at the original equation. We decide which one's easier. We substitute that value in for x, solve for y, and write our solution. So again, like I said, you guys did very well with that. I was pleased to see all of your responses. If you did not complete that, then please go back and make up that assignment. As mentioned, we're going to move into systems when both equations are in standard form. The links are there as a reminder to view them as well. And here we are in our first example. So I wrote that example here. Again, notice that both equations are in standard form. So when we are given 2 equations in standard form, what we want to do is look at the 2 equations and see if it looks like there's one equation where it would be easy to isolate one of the variables. And this is usually the equation that has a variable by itself. So if you look at the system, I'm noticing that in the second equation, y is already almost by itself. It doesn't have a coefficient. The only thing that's preventing it from being isolated is this 4x. And with our knowledge of literal equations, I know that I can move this 4x to the other side and isolate my y, which is what I'm going to do. So I'm going to rewrite that equation over here. I'm going to write 4x plus y equals 24. And then my goal is to get y by itself. Okay, so I'm going to now subtract 4x from both sides. And then these will cancel. I'll be left with y equals negative 4x plus 24. So now that I have isolated y, I can take this equation, I'm going to write it over here, y equals negative 4x plus 24. I can now substitute, let me get my blue marker. Come on. Okay, I can now substitute this value of y into the other equation here. So once I've rewritten this equation, this one we no longer look at, we're now focusing on this. So now that y is isolated, I'm going to take what y equals and substitute it in for the y in my second equation. So I'm going to write that equation over here. I'm going to write 2x minus 3. I'm going to put parentheses because I'm substituting in that value now. Parentheses. I'm going to put what y is. So y is negative 4x plus 24. And that equals negative 2. Okay, so I'm going to pause for a second and just go back so that we understand like where this all came from. So we started with this original system. right? We wanted to pick the equation that was easier to possibly isolate one of the variables. So we picked this second one because we said, all right, y is almost by itself anyway. There's no coefficient. All I would have to do is inverse that 4x to the other side, which is what we did. And now we have rewritten this equation into this format, and now I can take this value and substitute it in for y into the original first equation. Okay, so if you scroll through the lesson, I show doing that here. Okay, it's the same thing. This equation here is the same thing I just showed you here. Okay, and then we're back to what we did yesterday. So we're going to now distribute, because we have parentheses, so we would have 2x. Remember, this is a -3, so -3 times -4x would give us positive 12x. -3 times 24 is going to give us a -72 equal to -2. Okay? Once we distribute, then we look to see if we have like terms on the same side of the equal sign, which we do. We have 2x and we have positive 12x. So I'm going to put those two together and get 14x minus 72 equals -2. Now I have a two-step equation, so we should all know at this point how to solve these. I'm going to inverse my constant and add 72 to both sides. I'm going to wind up with 14x equals 70, and then we divide by 14 to get our value of x. So x is going to equal 5. Okay, so we did all this work to solve for x. We're still not done because remember we're looking for a solution, so we have to now find the value of y. So to find the value of y, we go back to our original system, and we have three equations to choose from now. We can either plug in x to this equation, or this one. Looking at these three equations, I feel like this third one that we manipulated is probably the easiest one to plug in x and find that y value. So that's going to be the one I choose to solve for y. So I'm going to rewrite that equation here, which is y equals -4x plus 24. Okay, I know that x equals 5, so I'm going to write -4 times 5. And then plus 24. Okay, I then do -4 times 5 is -20 plus 24. So -20 plus 24 is going to give us a value of 4. And now I have my solution because I have my x and my y. So once we have that, then we just write it as a point. So my solution will be 5, 4, right? X, y. So this is all of the work we needed to do to get to that one solution here. And when I asked to see your work on how you came up with the solutions for the 4 problems you're going to do on your own today, I expect to see this amount of work. Some of you were only showing me very minimal work, and it was not supporting how you arrived at this final answer. It might seem tedious, but this topic is, so you need to be very detailed and show me everything you do to get to that final answer. Okay, if my work is looking this long, then your work should look this long as well. And this does not apply to everyone because a lot of you did beautiful work. I just wanted to explain to those of you that maybe didn't receive the full credit you might have been expecting, why and how to improve upon that. Okay, so everything I just showed you is in the lesson as well. I take you through exactly what I just modeled for you, solving for the x. Ooh, it just got smaller. Solving for the y. Oh, this one, the answer is incorrect. We got to fix that. Okay, and then you'll have your steps here, and then there's a few more problems as well. So again, you're going to be given a system. They're both going to be in standard form. We usually pick the equation that has one of the variables by itself, manipulate that equation so that that variable is by itself, and then you use that to substitute in to the other equation. You're going to then solve like we have been. You guys have been doing very well with that. Okay, this one we wound up getting a false statement. If you ever get something like that where a number is equal to not itself, some other number, then that means that these lines must be parallel. There's no solution. A false statement means there is no solution. These lines would never share a common point. They would be parallel on your graph. Okay, here's one where we have both variables are by themselves. So this time I just figured, all right, let's solve for x. Since we've been solving for y, let's just change it up so that you guys see that you can do that as well. So to get x by itself, we would have to subtract y, and then x would be isolated, and we would have negative y minus 5. We then take that value of x and plug it into the other equation, and that would look something like this. Okay, where you'll see that value now is in place of x, and then you distribute, combine, inverse, you solve for the value of y, you'll then solve for the value of x, and write your solution. Okay, so there are a few more for you to look at, and then you have your 4 problems to complete on the Google form. I'm going to show that to you one more time. It's the same deal as yesterday. So you'll see your exit ticket as the Google form right here. You'll click on it. Okay, you'll have your 4 problems to answer. We made them multiple choice for 2 of them short answer. And then you have your 5th question where you're going to tell me how you're going to send me the work for the problems. Okay, to send me the work for the problems, it's a separate assignment. That's right here. I gave you the option of doing it in a Google Doc. Some of you typed right into this doc, which was awesome. I feel like that was like a nice, easy way for you guys to complete this. Others of you just sent me a picture of your work, which is just as good. And then others sent it to me through Instagram. Any way you want to send me that work, it's fine. And I will be happy to send you any kind of feedback to help you really master this topic. Okay, I hope that was clear. If you have any questions, please feel free to reach out to me, and I hope everyone is staying safe. Take care.